This is 7.4 in Advanced Algebra 2, Properties of Logarithms. It's a big, fat mess right here. Got a question for you. Let's do some inverse ideas. X squared times x cubed. Do you know what you are supposed to do with those exponents? Add them together. But what were you doing with these bases right here? What were you doing? Don't multiplication and addition like go together with each other when it comes to exponents and powers. It's like, oh, if you multiply some powers together, you add the exponents together. And then if you was to do something like this, isn't that a division problem right there? And what are you really supposed to do with the exponents? We always play where are there more, but what do you really do with those exponents? You subtract them together. Doesn't subtraction and division go together also, right? Well, it's the same concept with the old logarithms. You see, it's really small print here, I know, but you see the argument? They are like multiplying those arguments together, right? Well, what a property of logarithms says is if some arguments are being multiplied together, you can split it up. You can split those arguments up into an addition of logarithms, and don't they have the same base? Log base x of a plus log base b, I said that wrong, log base x of b. They can add together. What were they doing with these? One word. What were they doing with those arguments? Multiplying. What did we switch it to? Addition. Multiply and addition go together. Hey, what are they doing with these arguments right here? What are they doing with those arguments? Dividing them. What did they switch it to? Subtraction. So they're asking us here in example 1, there's some other properties that we'll deal with. We'll just get to them when we get to them. They're asking us to rewrite this to expand the logarithm, right? Split it all up. What are they doing with those arguments? They are multiplying them together, meaning we will split it up. How many arguments are there? Like how many things are in this argument? Isn't there 5, an x, and a y, correct? So we will split it up into 3 terms, and how will those terms be related to each other? They will be added together, and they will all be log base 10. So how about this? Log base 10 of 5, cool, plus log base 10 of x plus log base 10 of y. First question, do you understand what I did? Since all the arguments were being multiplied together, it is a property of a logarithm that says you can split them up as 3 separate log terms added together. Cool? But now we got to check to see if that can simplify. If any of the arguments are just a number, like that argument, isn't he just a number? We want to see if this can simplify at all. Like, is 5 a power of 10 at all? Like, let me give you an easier one. Log base 3 of 9. Right? Like, what if I had that written right there? Is 9 a power of 3 at all? What is log base 3 of 9 really equal to? This is really the number 2 right here, correct? Because 3 to the second power equals 9, correct? So this could have been a 2. Can 10 to some power equal 5? Yes or no? What about the 1/2 power? Is 10 to the 1/2 power 5? Like, is the square root of 10 5? Yes or no? So this is as simplified as it gets. You okay with that? Right? Next problem. Look at the arguments. Aren't they being divided? Right? How many numbers are in that argument? Or how many, like, they're not quite terms, but how many? Are there 2? So division means we will do what with those logs? We will subtract them. It's all going to be log base 3. And it'll be numerator first all the time, right? The numerator first, which is 14, minus the log base 3 of 5. Since the arguments are nothing but numbers, let's see if they can clean up a little bit. Is 14 any kind of power of 3? Is 3 to some power turn out to be 14? Nope. Does 3 to any power turn out to be 5? That's done, right? Division means subtraction, and it's to make it as simple as humanly possible. Division of arguments means you can subtract the logs. Whoa. Back to our chart. There's other things. The power property right here. If you've got, let me see if I can write this a little bit bigger for you. The log base b of, let's just say, some argument a to the x power. Do you see how the argument, right here, if my pen would work, sorry, if the argument is raised to an exponent, cool, here's a property of logarithms, that exponent gets to move in front of the log. So it could be rewritten as x log base b of a. For example, if I have log base 6 of x squared, does the argument have an exponent on him? So this exponent can now move in front of the logarithm to where that is a 2 log base 6 of x. You okay with that? So let's see what we were dealing with here. The argument is the square root of 7. Can you rewrite that square root of 7 with a rational exponent, though? What is the square root of 7 with a rational exponent? 7 to the what? So cross that out and just put 7 to the 1/2 right there. Isn't that really what the square root of 7 is? 7 to the 1/2. You with me? And why do I want to do that? Because now the argument is being raised to an exponent. And according to one of the properties of logarithms, where can that exponent move down to? In front of the log, right? So you've got 1/2 log base 2 of 7. That's all that can clean up to be. There was no multiplying going on with that argument. There was no division going on with that argument. It is just a radical. So I take a radical and change it to a rational exponent so I can bring that exponent down in front. Another one. Actually, let's just go straight down to number 5. That's supposed to be cube root of t squared, right? Okay, sorry for the computer glitch right there. But isn't this got a radical with it? The argument has a radical, correct? Let's rewrite him with a rational exponent. It's power over root. Power over root. You've got a what root? Third root and a second power here. Isn't this really t to power over root? Isn't that t to the 2/3 power? Correct? Cross him out. And now that argument has an exponent, where does the exponent get to move to? Front of the log. 2/3 log base a of what? T. Groovy? Let's jump up to number 4. Oh, man. This is the stuff that gets people confused. Like I said, if you have a question, holler at me right away. Okay? No radicals, correct? Just A's, B's, C's, and D's. Isn't there some multiplying going on, right? And some multiplying going on, and some dividing going on, correct? Here's the basic rule. Upstairs will be addition. Everything downstairs will be subtraction. Because let me show you why. Isn't this c really have a negative exponent on it instead? C to the negative first, isn't it really in the denominator? First, let's rewrite a few and then see if I can explain it after we do a few. But the division stuff has to go as subtraction. Isn't the denominator, the c and the d, in the division? Boy, I said that backwards. The denominator is the stuff that you want to subtract away. The numerator is the stuff you want to add to it. So aren't there 4 letters in this puppy? 4 different terms. All of them will be log base 3. So log base 3, let's start with our numerator of a. Isn't a the first letter I come across in the numerator? I'm done with him. Right? There's still a b upstairs, correct? So I need a whole nother log, and since they were multiplying, won't I add them? Right? So log base 3 of b. And I'm done with him. Cool? Since every variable left is in the denominator, subtraction is the operation that we want to use. So now, what's my next operation? Subtract log base 3 of c, correct? And done with him. D, where's he at? So what's the operation that we want? Subtract log base 3 of d. And people ask, it's like, but aren't those multiplied together? Shouldn't you add them, right? Not if they're in the denominator. It's a subtraction, okay? Let's see if you can understand it after this. What if I just wrote it as this? Right, let's say you had that. Is there a number in front of the log? What number's in front of the log? -1, right? Any number in front of a logarithm is really an exponent, right? Isn't this 2/3 the exponent of that argument? So this is really log base 3 of c to the negative 1, right? Doesn't the negative 1 come? And where are all of the things with a negative exponent really belong in a fraction? Where do they belong, in the numerator or the denominator? In the denominator, right? Because that's really 1 over c right there. C to the negative 1 is 1 over c. It's really in the denominator. So that's why there's a minus in front of it, because you want the exponent on this guy to be a negative 1. Let's try this guy. Whew! Go ahead. Next guy. I'm going to put him in a new window just to blow it up a little bit bigger. Tell me what you see for that argument. What do you see? What's the first thing that just shoots out at you? Big old radical, right? Means we need to rewrite them all with rational exponents. Isn't this really a second root, right? A square root? So let's just kind of do this. Since it's so messy, let's just rewrite this guy. Log base b. Each term, right, is power over root. So here's my fraction bar. Isn't the w upstairs? And instead of w cubed in the square root, how about w to the 3 halves power? With me on that? Power over root, right? 3 halves power. All good? How about the x? What do you want to write x as? X to the 5 halves power. And the y down here, 2 over 2, 1, right? Isn't the square root of y squared turn out to be y, right? And then how about the old z to the 9th? So we need the second root of it, so isn't that z to the 9 halves? Is everyone cool with just getting rid of the radical by rewriting it with rational exponents? Awesome. Now, we've got it all boiled into one. We've got some multiplying, we've got some dividing, and don't we have some exponents, correct? So, we could do this in many steps. And since this is the first one like this, maybe we'll do it that way. Or we could do it all at once. Let's do a few steps at a time. Is that all right with you? Let's rewrite it as this. Won't they all be log base b's? Right? So how about log base b of w to the 3 halves? What I'm doing is I'm just taking these 4 variables and I'm going to split it up into those 4 terms, right? So haven't we used him? Right? I need to do the x to the 5 halves next. Will it be a plus or a minus if that x is in the numerator? Plus log b of x. As he was in the numerator, the sign between them was addition. Cool? The next thing I want to deal with is the y's. Will it be a plus or a minus, though? Minus, because he's in the denominator, log base b of y. Is everyone cool with that? And finally, plus or minus b of z to the 9 halves. But we're not done. How come we're not done? All of these arguments have exponents on them, correct? Where do the exponents move to? In front of the log, right? So the next move is this 3 halves comes in front of this log, so it's 3 halves log base b of w, plus this exponent comes in front of that log. Then we got to be careful with our sign. This guy doesn't even have an exponent on it. Well, it does. It's a 1, so you just rewrite the same thing. But it's still going to be a minus. Cool? And then this 9 halves comes in front of the log, but doesn't the minus still have to be there? Right, so it's minus 9 halves log base b of z. Yes? Next one, 7. Why don't you and the pal give it a shot? Let's think about it like this for 1 second. Are there any radicals? Yes or no? Then multiplies and divides. Yes, what's the question? So pause the video, give that one a shot. So we're in class here, and everyone's done, but I want to do this problem. I'm going to make the mistake that I see most often with this expansion of logarithms. So I got log of 5 plus log of x minus log of t. What mistake did I make 3 times in a row? I forgot to put the little base, right? I forgot to put the little base of base 5. It's not a log, it's a log base 5. If I don't put a number there, what number is supposed to be there? 10, right? But these are log base 5s. Are we all cool with that, right? Is this done? Nope, because you look to see if you have any arguments that are just whole numbers. Can this be rewritten at all? 5 to what power equals 5? So this is really the number 1 right there. Are you cool with that? Like what we did last time was we'd say, all right, rewrite it with an equals x, change it to exponential, and solve for x. Correct? I'd like to stop doing that if possible. Can we just look at this and say the base to what power equals the arguments, right? 5 to what power equals 5? Isn't that answer 1, correct? So this is really a 1, and all this other stuff, since the arguments are variables, cannot be modified at all. That's our final answer. Anytime your argument is a number, look to see if it can be cleaned up. Okay? Next one. Do we have any radicals in this bad boy? Nope. So let's try this. I want to do it together. Now let's see if we can bring those exponents down before we have to rewrite all this stuff. Right? Aren't there exponents involved in this problem, though? So one thing at a time. Log base 6. The first thing I come across is a 36. Correct? So I will put a 36 there. Done with him. Good deal? The next thing upstairs is an a to the 4th. Since it's upstairs, what symbol will I put between these? Plus. Doesn't this exponent have to come in front, though? Right? Doesn't the exponent have to move in front? So what's the next thing you want to write? 4 log base 6 of, you see how I kind of killed two birds with one stone right there? Instead of writing log base 6 of a to the 4th, I just took that x4 and already brought him in front. All exponents go in front of the log. Cool? So done with him. How about the old 2? Since he's downstairs, what sign am I using? Minus. Is there an exponent on the 2? Nope. So minus log base 6 of 2. Cross him out. The b, he's downstairs, so I'm going to have a minus. Does the b have an exponent on him? So doesn't that need to come first? 3 log base 6 of b minus log base 6 of c. How do you feel about that? Cool. Let's see if we can clean anything up. Do I have any arguments that are whole numbers? This guy right here. Since the base is 6, does 6 to any particular power equal 36? 2. Plus, that's got a variable for an argument. Hey, this has got a number for an argument also. Does 6 to any particular power equal 2? 6 to the 1/3, like the cube root of 6 is 2? No? Yes, no? So, I'm glad we're thinking though, right? Because you got to think about those rational exponents. You know, it's like, is there any root? Like, first of all, is 6 to any power 2? Or is the cube root, square root, 4th root of 6 anything particular? And that answer was a no, and everything else had a variable with it. That's a lot of logs. Sweet. That was expanding it. In my opinion, I don't like the expanding because it's just a lot of writing. It's right. What we will do now is condense it. Don't they have it all split up in different logs? First thing you got to check for, look at all your logs. Are they all the same base? Is every one of these in our first problem log base 3? Right? We're going to condense it into one log then, and it will be log base 3. That's it. That's the only time you'll write log base 3. Cool? Question. Will this be a fraction for my argument? Is there any subtracting going on between these terms? No fraction. It's all adding, right? Adding. So aren't all these numbers, the 7, the x, and the y, supposed to be what then? If they were adding those together, they should be what? Multiplied together, 7xy. Good deal? Notice there were no exponents either because the number in front of the logs every time was a 1. Done and done. Cool? Next guy. Are the logs in the same base? Please ask yourself that question first. Are the logs in the same base? So they're all log base 5. Cool? Now, here's how it really works. Look at this term. See, there is an exponent in front of this, right? But what kind of 3? Is that a positive 3 or a negative 3? So that means that this guy is upstairs, right? This dude is upstairs. Cool? Will there be a fraction on this one? Due to the subtraction. So I'm going to start with my fraction bar right here. What's upstairs is p to the 3rd, right? Because doesn't this 3 have to come up and become an exponent on that p, right? This would be the negative part. Here it is. That's your fraction bar. Cool? It's really q to the 5th. Y'all good with that? Awesome. Let's try this one. Are all the logs to the same base? So it's log base 10. Is there going to be a fraction in this at all? Due to that subtraction, we will need a fraction. Where's the 4 at, like in this first term? Is he upstairs or downstairs? Upstairs. Cool. Where's this x at right here? Upstairs or downstairs? Well, the sign in front of that will tell you, since it was a plus, he's going to be upstairs. Cool. See this red term right here? Isn't the subtraction in front of that? So this is going to go downstairs. Is there an exponent that needs to come up also? So what do we got down there? Y to the 4. Cool. Next one. Are the logs in the same base? Notice the quantities involved with this. That means that the argument is that entire quantity, right? You know, they can't write it like this, log base 5 of x minus 3, because this is not a part of the argument anymore, right? It's like that got translated 3 units down or something, you know? But if you put the parentheses in there, that's still a part of the argument. Cool? So let's roll with this. Are the logs in the same base? Log base 5. Sweet. And this guy, isn't he upstairs? And tell me about this guy. Where's he located, up or down? So I'm going to start with a fraction mark. Because of the subtraction, there's a fraction. 2's got to come up. X minus 3, but that quantity has to get squared. And y plus 4 quantity cubed. Feeling good with that? Go for it. 2 more. Try 13. We'll see how we do. Okay? One thing at a time. Are the logs all the same base, first of all? So here's where everything went. This guy's upstairs. 2 comes up. This guy's downstairs because of the minus. Had no exponent. This guy's upstairs. Exponent of 1/2. This guy's downstairs because of the minus. Can anything clean up? Can anything clean up? Can anything clean up? Do you know what 3 squared is? So since that had a number for a base, don't rewrite the whole thing. You know, it's like if you want to just grab the old eraser and say, that's really 9. Cool? The other things you should look for is any of those numbers that are in there, what if they were a power of the base? Like, is 9 a power of 7? Yes or no? No. Is it root of 7 at all? Right? Neither. So, but if this was like a 49 right there, then that wouldn't be as simplified as possible. Yes? So, let's try the last one here. All log base 2. Where's the first guy at? Upstairs or downstairs? See, a lot of people assume the first one listed is always upstairs. It's about the sign in front of it. He's downstairs. So that's really a 15 down there. This is upstairs. That's x to the 1/3. This is y down there. And this is z to the 4th downstairs. We're all good with that? Mm-hmm. Your turn. 4 problems right there. Pause the video. Get all 4 of them done. Okay? And then check back with me. Please do these 4 problems out there in video land. Then check. Here's what we got. Video people, you can check yourself. Watch that your log base 8 of 64 turned into a 2, right? Other people were asking where this 1/3 came from right here, because this is really p to the first, and there's a third root. It's power over root, 1 over 3 in that situation. Those are all expansions, right? Because there's one log, and the argument has a bunch of stuff going on in it, right? The argument can either be multiplying, dividing, or have some roots in it or some powers. We got to clean that up. These are all needing to be condensed. A bunch of logs with the same base. So let's do 19, 21, and 22. Those three, and then let's do number 20 together after that. Do 19, 21, and 23, and skip 20. Condense the logs. 19, pretty simple, right? Please put the 5 in front of the variables, though. You know, like if you have a constant and variables, constants always come first. 21, pretty simple. 22, not even close to done. A lot of cleaning up to do. Are you cool with where everything is located, upstairs, downstairs, and the exponents that they are raised to, right? So I'm going to just start over. Instead of erasing, everything needs to be fixed. Log base 9. 2 to the 5th, how much? 32. X to the second to the third is really how much? X to the 6th times another x. Aren't these all base x right here? Like so, x to the 6th times x, how much? X to the 7th. 3y quantity squared. What's 3y quantity squared? 9y squared, right? Where does the 9 go? Front, y squared here. Can 32 over 9 reduce at all? Yes or no? No, we'll leave it like that. Okay? We'll leave it like that for today. Let's do 20. Three ways. That's why we skipped 3 different ways to do it. First, let's go in a new window so I have the room to do it 3 different ways. They want us to condense it down together, right? So, are they all log base 4s? Yes or no? So that's log base 4 of that 16x to the 1/2, right? Isn't he upstairs? You all cool with that? And then the plus means you're doing what with these? Multiplying, and isn't this going to be upstairs also? 2 to the 4th, right? So, that can be cleaned up. It's log base 4 of, what does 1/2 power really mean you're doing here? Do you know what the square root of 16 is? It's 4. So 4, but the x also has to be raised to the 1/2 power, right? It's like both of these have to be raised to the 1/2 power. And what's 2 to the 4th, baby? 16. Right? That can still be cleaned up because you have 4 times 16 in there, which is how much? X to the 1/2. Right? If you left that, we would accept it. But you see that this number is a power of that number. 4 to what power is 64? 3. So there's ways around this to make it even more simpler. And what you have to do is split it back up. Right? We're trying to condense it, right? And in the condensing process, we have to split this back up as this. Don't write this any further. Just leave it. Just watch me. Log base 4 of 64. What's going on between those? Multiplication. So how do I split it up? Plus log base 4 of x. And the 1/2 came down, right? Because what's this? That's how much? 3 plus 1/2 log base 4 of x is also an accepted answer. Problem? It's like 2 terms. But how many logs are in it? 1 log. It's like weird. It's like, did you condense it? There's 2 terms. Well, you condensed it down to 1 logarithm, didn't you? Plus a constant. That's the second way acceptable answer. The third is, check this out. Isn't this really log? Come on, brother. Mr. Penn, don't die on me. Log base 4 of 2 to the 4th, right? Well, what's 2 to the 4th? What's log base 4 of 16? It's really a 2, right? Isn't this term right here 2, right? So your answer could be 1/2 log base 4 of 16x. That was this guy, plus 2. Log base 4 of 16x to the 1/2 plus 2. Log base 4 of 4x to the 1/2 plus 2. And then we can split that back up again also, because it's a 4 a power of 4, right? And it's like, more than one way to skin a cat. This is the answer that we're looking for in this system, though. Okay? Now, I got some more problems. Dang it, I had some more problems, but remember my slideshow got deleted somehow. Okay? I got some more problems for you, so I'll just make them up on the fly. There's one more exponent rule that we have not talked about today. Log base a of x to the a. Right? Let me use numbers instead. Log base 3 of 5 to the 3rd. Any guesses before I'm done? Like, can you simplify that? What do you think the answer is? Wait a minute. Yeah. So I'll watch this. I did it wrong. Remember, I'm just making these up off the top of my head. I want to do this. That's what I want instead. Even though that other one was possible. Any ideas? What the answer would be? So let's do what we did before. What we're going to do here is a bunch of non-calculator problems. And I'm asking you to go straight to the answer, if you know it. If you don't know the straight to the answer, here's what I suggest. Throw that on there. Correct? And now, let's rewrite it exponentially. What's the base? 3. What's the exponent? This is the argument, correct? That's the argument, right? What's the exponent? X. That should equal the argument. What's the argument? Solve for x. What's x equal? X equals 5. The main question is, every time when you have it written in logarithm, 3 to what power equals the argument, correct? So 3 to what power equals 3 to the 5th? What would be the answer? 5? So how about this? Log base 6 of 6 to the 7th. What does that equal, baby? 7, right? Log base 100 of 100 to the 13th. What does that equal? 13, right? Log base a of a to the 5th. What does that equal? It's 5. Cool. So here's some other non-calculator problems that I'll just make up. Wow. Log. What is log base 10 of 100? What's that equal? The way I want you to think of it is 10 to what power equals 100? 2. That's the same thing, right? Log base 2 of 8. 2 to what power equals 8? 3. These are all your non-calculator questions on the test. Log base 5 of 25, what's that equal? 2. Right? 2? Ready? What's the answer? 1/2. Didn't we do a bunch of those back here, right? If the bases are the same, right, the answer is the exponent. Aren't the bases both 6? Because that's really 6 to the 1/2. Y'all good? Now here we go. 8 to what power equals 2? Is this bigger than that? That means you need a fraction, right? You need a root. What root of 8 equals 2, baby? Cube root, right? So how do you write that? 1/3. Now let's say you were stuck. If this is your non-calculator test and you are stuck, here's what you do. Correct? Then you rewrite it. And then you're stuck again. You're either stuck or you're stuck. But the question is 8 to what power equals 2? X equals 1/3. But this takes too much time to do that. And it's the non-calculator test, which we will have a calculator test in the same day. We need that non-calculator test to be done quickly, right? Should be real fast. So we will practice, 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 practice.